Hi, my name is Olivia Pacheco and I'm a senior mechanical engineer here at Uson. Today I'm going to go through how to create a program for your leak test on your Astra Dash. Next to me I have an Astra Dash configured with two installed channel boxes. These are licensed and configured in two different ways, and we're going to write a program for them. We start out on the home screen. I've already logged in, so I have credentials to write a program. And to begin, we're going to go up to the main menu, which is in the top left corner. Go to Program Setup. And here I have a list of all of the programs that have been written and saved on this system, whether it's for installed channel boxes or those that have already been installed and removed. They'll still be here in this list. I can only write a program for those that are currently installed. So we're going to write it for channel 1 with this catheter installed here. So if I press this plus icon here, and you'll see we have three options. We have guided setup, which is the one that we're going to go through today, and that's going to walk us through step by step. You could also start with a blank program if you know what times you need for each of your steps, what limits you need, and you want to just enter those manually. You can also copy the program if you have something very similar and you just need to make minor tweaks. You can copy one that's existing in this list. Today we're going to do guided setup. The very first step in this workflow is to choose your model type, and that's going to show you one tile for every different configuration that's currently installed. Since, as I mentioned, these are different, I'll have two tiles. If they were the same, I would just have one tile. And this is going to show essential information about this channel box. So what sensors we have attached, which regulators we can use, test types, and which options are available to us. Once I select that, I need to choose my test type, and it's only going to show which test types are available for this configuration. We have pressure decay, occlusion, and back pressure flow for this channel box. Now I can choose this manually if I know which option I want. If I want a little guidance from the system as far as which test type is right for this part, I can go through our wizard and say, make suggestion. What we have connected is a dual balloon angioplasty catheter, and we're going to run a leak test on the outer balloon. So in this instance, the first question the system asks me about my test part is, what is our goal? With this outer balloon, it would be leak tightness. But if I were testing on the center lumen, I wanted to make sure it's not occluded, I could say I want to check the flow through the part. If I had a check valve and I want to know whether or not that event has occurred, then I would say check event. And then it will continue to ask us questions in order to refine and narrow down that list until it has a final test type suggestion. For us, we're going to do leak tightness. And that's the only question it needed to ask me in order to suggest that I use pressure decay. Now, it's highlighted pressure decay tile, but I don't need to choose it. You're not forced to. I'm going to go ahead and follow its suggestion. Next, it's going to walk us through the quick setup. You may recognize that workflow from some of our other products. This is going to give the system information that allows it to calculate and draft your initial program. It's going to use the test volume, the leak threshold, your target pressure, and the tolerance around that target pressure in order to write in all of the values that you need in your program. So how long do the steps need to be to fill that part? What should my limits be around the fill pressure and my allowable leak? This is going to populate all of that. I'm going to enter this in really quickly. Let's say that I have a 10 milliliter part and 3 cc leak threshold, and I'm going to run this at 5 psi. Plus or minus 10% is fine on the fill pressure for me, and then I'll say apply. It's going to take us into the next option through this horizontal workflow, which brings us to coupling, and we're not going to talk about that today. Then we go to regulators. Now, these channel boxes have manual regulators, so the system's going to give me an opportunity to check that those are set properly before I save my program. What I need to do here is open the front panel so that I can access the manual regulators here at the front. And I'll activate the channel and see that I'm set I'm already set to about 5 psi, which is all that I need. So I can deactivate that now. If that was not set properly, I would just need to adjust it, and I can monitor that sensor reading live. Okay, since that's set properly, we're going to move forward. Now you can see the program that has been drafted. The system's already put in the duration for each of these steps for a gauge decay program. It's already populated the limits. So you see that I have my plus or minus 10% around the fill. And it's given me an initial threshold for my leak as well. Now I can make changes here if I'd like to. So if I see anything that needs adjustment, I can do that now. This looks pretty good to me, so I'm going to go ahead and move forward. Which brings us to the sandbox, where I can run this program before I ever save it. I'm going to go ahead and press start. So I'll be able to see this test run through its entire duration. Now, looks like we're leak tight, but you'll notice the balloon didn't inflate. So this gives me an opportunity to say, I forgot to open this part. And now, without logging any data for these results, I can run it again. Now the outer balloon is inflating as intended. We can make sure that I got to my fill pressure, all the steps are passing as expected. And that was a successful test. I'm ready to save it. Before I save it, I'm going to change the name. I can change this to anything I want. We're going to call this Astra Demo. One other thing before we save this revision, you'll notice the CRC at the top of this screen. And that is an algorithmically determined value that's specific to this program and all of its parameters. So as long as the CRC is matching, then all of the program information is the same between two programs. So I'll have the program name, the step duration, the pressures and the limits, all of that information is captured there so that I have an identifier to say that I know exactly what that program contains. And that will help the user to make sure that no changes have been made to your program. So you can look at the revision, but the CRC will give you a nice indicator that this program is not changed. All of its values are exactly as I released on my last CO and has been validated against. Now we're going to complete the setup. And that has been saved. We have Rev 1 and we have our CRC. If I want to make a change to this, I want to have a little bit of a longer fill step, you'll see the CRC adjusts, the contents of the program have changed. And then if I save it, and with that, our program is now saved and ready to run. Thanks for joining me for this intro on program creation for the Astra Dash. Stay tuned for more content exploring the features, applications, and use of the system.